Welcome everybody, welcome to week 4 of Design 2. We're doing this online now due to circumstances, as we're all aware, so we won't dwell on that too much, but we'll just move on quickly with the exercises for this week. What I'm going to do is give you some examples for how to draw objects like more complex cylindrical forms, like the objects in the view here, things like door handles, maybe an exhaust pipe, objects which clearly have a kind of center line which moves through space, sometimes in X and Y like the door handle, but sometimes in X, Y and Z like the exhaust pipe, or like something like the Hoover pipe here. Okay, so without too much chatting through, we're going to move quickly on, and we're going to start off by looking at the door handle and see if I can give you a basic kind of demo of how that might actually work. Okay, so let's take it from here. Okay, so if we now have a look at how we draw something like this door handle here, fairly simple geometric form. We need first to consider things like center lines, and also things like vanishing points and perspective. So we'll sketch it from an angular viewpoint, put in a center line. This becomes, let's see, one vanishing point. The second vanishing point is going to be over here somewhere, and the center lines are going to extend here to going to be a little bit longer, to make sure that actually does converge a little bit better. So we have effectively a longer center line and a shorter center line for the end of the handle here. This is going to be the point where it joins onto the door. At each point on this thing, at each geometry point, we need to define a center for an ellipse. But first we need to define the radiuses that define the actual way that the handle bends. So we'll create a couple of sections here, symmetrical points on the center lines, and use these as a reference for sketching an ellipse, where the ellipse center will be there. It's effectively going to be part of a vertical cylinder, so it's going to be horizontal on this plane. If we sketch in an ellipse cylinder which is going to be roughly tangential at that point, you can see that that center line will follow. You have to draw the ellipse, not perfect, but it's going to draw a point like that. Same thing down here. It's going to be arcs on this line here, thereabouts. So we're going to have an ellipse which is following probably around about this curve. So that's going to come in and something like that on this radius, maybe a little higher. Take through a tangent pointer here. That's going to be our center line there. It's not very tidy, but we'll go with it for now. Center line here and center line through the end point is going to be here, so we need a 90-degree connecting line there, and the other end point is going to be over here, so there we need also a 90-degree point. At each one of these tangent points, we also need lines which cross here at 90 degrees to define the symmetry of our elliptical form. So we put all those lines in, we can then start to think then about the size of the actual object we're drawing. If we pick 2 symmetrical points here and bring those through here, that gives us 2 points on this one. Take those points through here a little bit. Here they're going to be a little bit smaller because it's further away, so it should appear to get a little bit smaller. And here again, take around about the same. Take those again away a little bit, maybe make that a little bit more dramatic, a reduction there, to give us those center planes of the cylinders, which means then one ellipse will be sitting about here, maybe a little bit broader because it's gone away from us. This one will be again about here. Again, should be a little bit bigger than the one in the distance. This one will sit around about this point. These are 45-degree ellipses effectively. These lines are all about 45 degrees, so you can imagine we have a kind of 45-degree viewpoint from this object. We're quickly sketching some ellipses like that. Probably this one should be a little bit wider. I won't do too much. This one as well, because it's further away, should be a little bit rounder. Something you just need to look at and be critical about. These should all probably be a little fuller. What we now need to consider is what happens on the corners. And what we need to think about is at this point this center line comes around the corner. At this point it's actually travelling towards us in space. This center line comes around the corner. When it meets the midpoint, it's actually travelling horizontally. So the ellipse at this point we don't see. It becomes a vertical side elevation. Here at this point, because we're looking at it coming towards us, it's going to be more or less a circle. So if we sketch a circle there which is approximately the same size as the ellipses around it, We can see then that the edge of the cylinder is going to come around this corner, it's going to touch that circle and come travelling around the side of the circle effectively, and come around to make a tangent with this point here. This line, the back edge of the cylinder here, comes along and comes through, and we don't see too much of that, but what happens is it just has a little kick as it goes in towards this point, and that's a little bit pushed away by the heavy centre line here, so I'm just going to take that centre line back a bit to bring some clarity to what's going on. And here we've got the same thing on this side, whereby here then we have a tangent line that comes from the two ellipses, this one here, so from this point to this point, and that makes one continuous curve which more or less follows the line of the centre line, and here this line does much the same and should come round, and here's a little bit fat, which means I haven't got these ellipses quite right, but we get the basic idea. That gives us the form in perspective that we're looking for. If we tie that up a little bit, bring some definition to the lines now, a little bit of line weight where we want it, take this a little bit heavier, bring that round, make this a little heavier, clarify that point there. And again, I'm going to use the technology just to clarify things for you. It's rather less sensitive, this drawing instrument, than a pencil is still. Bring this in, clarify that ellipse there a little bit. It still looks a little bit strange because it's kind of floating in space, but if we then then sketch the actual line of the door plate where this handle becomes connected to the door, we sketch basically a block that runs down and through that. This will help to fix this in space a little bit, making sure that we use the centre lines of the cylinders to give us an idea of our vanishing points, to make that a little bit consistent. Sketch it playing there, coming down through space. It really starts to make this look like a door handle. We could really go to town on it and put screws and a lock on it and all that sort of stuff, but in this context we're not going to do that. Okay, so we can see then how we can position those ellipses to give us the idea of that object moving through space and rotating around the corner, and really thinking about where does the centre line run in relation to us. That allows us to predict better where the ellipses are going to lie. And there's the door handle. Now, having drawn that door handle from one perspective point, it's worthwhile considering the problems we face if we want to draw it from other viewpoints as well. Let's imagine we want to draw it maybe with the centre line running in, let's say, coming vertically down in this direction. That goes off to one vanishing point, and then the other lines come off here, and the shorter line will be at this end. Now we need to think a little bit about the foreshortening. We need to think about the fact that this line would get shorter depending on our viewing angle. It can be if you view it from a slightly flatter viewing angle, where it's coming towards us. It could be that this line is here and this line is here. We would only really know that by the position of the ellipses that we would define and how well those cylinders would actually overlap each other. So we then have here pretty well a circle at each one of these points with a radius here. At this point and this point we'd have effectively circles because the centre line is coming towards us. We'd have a sense of 1 point perspective. This would appear to come round over the top of this one. This would come round the corner here. This would come back along and round again a circle in that corner to give us a sense of that radius form. And that would appear to disappear behind this section if that was running more angular towards us. Yeah? So we have to bear in mind that things kind of tend to overlap each other depending on our viewing angle. And obviously in this particular view, then the plate at the top would be much more in this kind of position. Something like that. Probably even flatter in fact. Yeah? So we have to start thinking about how those ellipses would look from different viewing points. Yeah? So here we have this line, this radius. The ellipse on the centre here would be more like this kind of point. The opposite centre would be the opposite shape, doing something like that. In the centre we'd have a circle pretty well, and then these ellipses on the end would be much smaller and much thinner. And if we think about how we can help construct those kind of things with objects where we don't have straight lines, for example, an object like, let's take for example a donut, which has a constant radius, constantly cylindrical form, we could take that as an example and start by how do we actually construct such an object. Our little donut here, if you think about what's happening with that, essentially what we've got is then a cylindrical centre line. Part of an ellipse is a centre line, which is again symmetrical on two axes. And at each point on that ellipse, if we take the basic geometry points, if we pick these 90-degree points and then lines at say 45 degrees to give us references, at each one of these points we have centres of ellipses which meet the centre line at 90 degrees. If we then think about how big we want our cylinder to be, we map that onto those centre lines. Take it onto the vertical, but here it's travelling towards us. Here as well, again make it roughly 90 degrees to that centre line. It's going to come round something like that. Probably we'll make this one back a little bit smaller. It's going to come through here. See, that centre line doesn't have to be that clear. Here the ellipse, or at least a section of the donut, is round because that centre line is travelling towards us in this direction. Here it's travelling across our view, so the ellipses will be side elevations, and here because it's travelling pretty well towards us, they'll be almost round, not quite but almost. In between those, each one of these, because that's travelling across our view at around our 45 degrees, the ellipse would be still quite open, but not as open as it is on the centre tangent points. So we end up with something like that. If we then take the top points, or the edges of the ellipse, and connect those as tangents to each other, so we'll bring a line through here, through this top point here, through here to here. The same thing at the bottom, a line that runs around through here, through this point, through this one, and through here. And smooth it off in a minute, it's looking a bit angular, but we'll get to symmetry in there. The same thing at the bottom here, a symmetrical line connecting these points, and the same thing at the top of the line coming off here, following that round, again looking always for the continuity of the curvature, that means it's coming around here and joining to that without really making a big step, which isn't always easy, as you see. And then we have a little bit of an overlap here in the middle, and then we've created our donut. Now that works quite well with objects with a constantly changing section. Also depending on our angle view, of course. Here we've got a fairly similar angle view to this one. The amount at which you see in the middle is dependent on the size of the radius and our viewing angle. If we take a similar viewing angle, we'll make the radius much bigger. So we have these two sections. And we take, say, a viewing angle which looks about the same, where here we have our centre lines here and here, here and here on the main centre ellipse, which will then run something like that. It's about the same shape of the ellipse. We can see then, if we connect these all together, do some further ellipses in between here, here, here and here, that the section we get is rather tighter. You see just a very small amount now of the hole through the middle. This one running through that. And that's then a function of the difference in distance, the difference of diameter, and the space effectively that we're left over when we've drawn the rest of the form. And again, if we take a much smaller, maybe smaller section, we see a lot more, and it becomes actually, to be fair, rather more difficult to draw. If we take a section like this, put this in, and create then a smaller circle here and a smaller circle here. Replicate that here with sections, give us the height of the sections again, put in 90-degree lines at around about 45 points, take those heights through so they're reflected here, here, here and here. We then get a slightly different set of conditions whereby we still have our 45-degree ellipse. Here we've got our straight line, let's put those in all over. We then get something that looks much more like a large O-ring than perhaps a donut. We fill that all in. But it's important at these corners that we keep the roundness of the ellipse there, and that comes in and seems to go away. That point just here, as that travels away from us, is in that overlapping corner there. This area is really important in defining our view. That should be a little bit softer there. That should probably be a bit softer there. But that gives us then a different view of the donut, which is probably a bit thin and less convincing than this one perhaps. But again, you get the idea. And so if we have a form which is made up of constant sections like this, in this case it's a ring which has a fairly standard geometry, well, we could also say take a tube that runs through space. If we have a tube that runs through space like this, we apply the same basic principles, center line at 90 degrees at any point on that tube. Here it's travelling pretty well across our view, so the ellipse would be quite small. We take that as the size. Here it's going to be about this wide, here about the same. Here it's travelling more towards us, so here we see a much fuller ellipse form. Here it's come around that corner in a fairly tight radius. I'm probably going to create an overlap here because I've made the ellipse a bit too big, I think. It's too tight a radius. But at this point it would then be travelling towards us with a curve like that. Here it's travelling across our view, so again it's a little bit smaller. Here it's pretty well side elevation, here again, and here it's travelling more towards us, so it would be a fuller ellipse. We again think about connecting all that together, try to keep the connecting strokes as smooth as possible. Think about the curvature that you're trying to create. It's going to come around here, for example, at this point. It will help us if we've got a circle in there on the right size, because we can then say that's going to connect in and come around and create the correct kind of flow, and also reflect the tightness curve we're going to get here. It's looking a bit thick in the middle. We'll go with it. That again is going to come round to a tangent point here. Give us in this section, in this section. So we've probably made it too tight a radius here to reflect the size of the actual diameter. Obviously, if we take that same curve again and we make the diameter smaller, we see a better progression of the form. And make sure we're sitting roughly at 90 degrees to that, where flow is a little bit easier to describe. So we need to watch out for that. And this same basic principle can also be applied to objects which are not cylindrical. If we want again an object which is moving through space but has a rectangular form, whereby the ends are square, we still have the same basic reference system where now we take the edges of the boxes as vertical lines, sketch those squares in the start and the finish. That gives us our good clear reference forms. They should look like it's a little bit smaller in the distance. If we put in these lines now, the centre line of the square at each point, and make sure that crosses again our centre line at 90 degrees, we can use that to create progression. It should look here a little bit shorter because it's side view, so it's going to look a little bit smaller to allow for the reduction in perspective. Here it starts to come towards us, so it'll get a little bit bigger. We then need to think about the vertical lines coming up off this to define the height of each box, and then think about the height, which would be fairly constant. That won't change very much as that goes round. The bottom height again will be symmetrical on those centre lines. Come through. We then take these corners and join them together. Again, try to use, as far as you can, smoothly flowing changing lines to sketch this. It gives us then a sense of an object which is moving through space. The box section, we're going to have something like that and draw that detail. It's probably also worth mentioning that this one doesn't really have quite the perspective kind of dynamism you'd really want, where it would probably be better if it went smaller to larger, and now we're doing it really extreme, of course, but whereby we might have a more dynamic changing section, probably something like that might be better, which would allow us then to understand what's going on with the sections running through, make it a little bit more interesting, a bit more perspective. If it's coming towards us, of course, it can be that it starts there, travels along. And we've got to think then about the changing sections according to where we might see this getting thicker or thinner according to where we view particular bits of it from. So those changing sections are really important to consider because they can help to orientate and give meaning to the object itself. And feel free to play around and to play with just sketching it and getting a loose idea of how it works without having to go through too much heavy construction. Just try and get a feeling for how you can sketch these kind of objects. Okay. So if we now look at what happens if we introduce changing sections into this equation, instead of having constant sections like we have here with the cylinders or the donut, if we have changing sections, life gets a little bit more interesting, and that will be an example of something perhaps like the exhaust pipe here, which has a tube, it has then a conical section, a straight section, conical section, a radius cylinder, tubular section, and then another cylindrical section, and this bit that comes down off the side here. If we try and draw something like this, we need to think about building up different sections, different dimensions, different points in space, but still maintaining the same general perspective geometry. So we'll have a go at something like that now. There. And with something like that, we need first to consider, we look at how that object actually works inside elevation. It has a line that comes down. Don't worry about this one too much, where that pipe's coming from. It comes along a straight line through the main conical form, cylindrical form, conical form of the exhaust, and then that goes round a path which is part of a circle. Maybe not quite as big as I'm drawing here, but just something like this. And then that centre line comes down again with that conical tube attached to it. It does something like that. And then comes off. And that tubular section coming off there. Comes off, comes round, and then comes down over the top of that other tube. So if we need to get this, what we need to do is basically establish this form as it comes around here where the centre line runs in one plane. So we can do that in perspective. We take the baseline for the perspective, take a line vertical up to represent the centre line here, this point. Think about that centre, and then where that might travel towards that centre, where that comes over a little bit and then comes back down to a point, let's say down here somewhere, to give us that changing section. Then what we get then, if we then establish our ellipse there, which of course is an ellipse which is now running in that direction towards perspective, we then have this as the centre line, coming around here, coming around this corner, coming around to meet that. This becomes the centre line, and we have the centre line that comes off here and comes down along there and comes around to give us that last bit of a twisting pipe, and that comes then vertically down here. At that point it's travelling that direction. This pipe that comes over here I'm not going to worry about just now. So here we then have a cylinder which actually in our view is going to be pretty well at 90 degrees because the angle it's looking at, although it's probably sensible to sketch a little bit of an ellipse on it to give a sense of what's happening with it. The conical ellipse underneath for the exhaust pipe, for the silencer, is going to have different sizes of ellipses which will have something like that going on. So at each one of these points we're going to have ellipses which are again angled to our view. These two, the conical sections, the cylindrical section, they're the same. Here we have a smaller one that cone forms. You should get the symmetry there, it's not quite symmetrical as it should be, fix it later. And then this is a longer cone which comes over to meet that, so we end up with something like that. Now the question is, of course, if we have this one standard vanishing point, that means that these also have to be going off to the same vanishing point, which looks about right in this view. And then here we've got to think about our ellipses again to form this pipe, which is going to come up, come round out the centre of this, come round in a little bit here, and then join in at the top of there. Here we've got an ellipse here, we're going to have ellipse here, and ellipse here. All these ellipses are 90 degrees to the centre line. Anyway, we sketch them. There's going to be smaller ellipse sections, so we can create a pretty well constant section through here to define how these go. And then once we've got those basic sizes, we can then think about the format they're going to be in. This one, for example, at this point, one at this point, meeting that 90 degrees, is almost flat, so it's going to end up being something like that. Here, this one, something like that, probably a little bit wider at that point. Here it's going to be a slightly flatter ellipse to us because it's going away and up. Here again it's going to be even smaller. This one is pretty well flat to our view. Here it's starting to come towards again, so it would look a little bit like the ones on the cylinder. Here we see rather more of it, and these are sort of 45 degree ellipses. And here at this point, this one is again coming round and would look something like that. If we then connect all that in, think about the outside form of what we got there. It's important to try and maintain the cylindrical form. It's maybe a little bit tight on the top here. Maybe we should do that bit again, but time being what it is, I'm not going to do that. Take this through, bring it round, and that should come round and appear to come round into the top of that tube there, a bit like so. It's not quite got the flow I would like here. It's going to look like it overlaps a little bit here, but it's not quite got the right flow on this point. I would like it to be more of a cylindrical form, where those ellipses are coming around and mapping around that. I'm really giving a sense of that. The transition shape that comes around like that and comes off. And getting those things to look truly correct as radiuses in this context are quite difficult to appear. Still not very good. No? But in essence, we then get this one coming off, this ellipse comes around here, this is come towards us so it's a bit fuller, comes down around here, so that ellipse will come down around and do that way it's coming around the pipe at the bottom, and here as that comes through it comes straight out and get that elliptical form there. So we get then something that looks a bit like that. But that all comes from getting that centre line in the correct place. And here this is not really working the way I like it. I think probably these ellipses should be rather rounder here. And that will then bring that round a little bit more towards us, and that's part of the problem. And make them a little bit too flat. But the same principle applies of working with the centre line. And if we do it from the other direction, we take the other option, we can take it from this side, take this line to come up, say that the radius is now sitting at this point, so we have then our ellipses coming around here. This one's going to be flat, this one's going to be at that position, something like that, and it's going to come round. It will appear to tighten up a bit at the bottom. It's going to come round and up and around this point, do something like that, and then go away again, where that becomes much rounder. And here then that comes down to meet that pipe here, where we then have a bigger cylindrical form. And here we can place our other ellipses to give us the conical sections. And again, make sure they're symmetrical on that X line to give us and the last bit where that comes down, comes around. Again, sketches and blue lines to give you a feeling for how that goes. And do something like that, and here it goes away off in the space again. So it is possible to, through these basic principles of placing sections, points in space, to create fairly complex forms that look and work okay. This one isn't working as well as it would. There's some other sketches which I'll place in that you can have a look at, which work rather better in this respect. The other beauty about this is, of course, if you need to put a sticker onto this, let's think again where the vertical centre line might be on this. And here it's not a vertical line anymore because this is angled towards it. It's going to pass something like this through here. That would then be the point where, if you had, for example, a sticker on this thing, it might be placed on that plane. Yeah. Here again, sticker might be on the side of it, so the sticker would sit in this particular position. Yeah. Okay. So the exercise for this week, then, for homework and everything, is to work on these basic principles of trying to construct objects where you have a sense of flow, trying to create a sense of movement through space with center lines and so on, and thinking about how ellipses would sit at those particular points when you're sketching such objects, and use that as a way to construct. I'm going to see if I can do a better job of making this pipe work, because at the moment I'm not very happy with this. Okay. And here's a couple I prepared earlier, which I think are a little bit more convincing than the ones I've just done in this presentation.